game. So anyone notice that? Anyone look at the key and notice there was some like, wait a minute, I didn't get the same answer. Anyone do their homework? Anyway, sorry, starting a movie with that. Kids not doing their homework. All right, so what we're doing is completing the square in this parabola. And it's a parabola because there's only one squared term. Went through this with a student. Got to group these two terms, pull out the 3, and then complete the square. But no, you didn't add 16. You added 3 times 16. And then what do you do with that 3? You multiply both sides by 1/3 so that you could see that 1/3 as the 4p position. All right, just got to have this memorized in a quick format for, in our case, Tuesday's test. All right, talking with, was it Beatrice? And I think I just had you factor and find the vertex. So I think you're good. Oh, Beatrice. That's a double whammy. All right, so which way is this going, Beatrice? Is it going up, down, right, or left? Keeping you on task here. You are correct. And I'm not going to graph this. All you need to do is this. Okay, fine. It's going up. So where's the focus? Is it above, below, left, or right of the vertex? Serial bowl table. Just where does the focus belong? Above, below, right, or left of the vertex? And it's above P. And then where does the directrix belong? Up, down, right, left. Down, and what kind of line is it? Don't say straight. Don't say dotted. It's it's horizontal. It's horizontal. So we got to know what the equation, and that's P as well. So that's the point of P. What is P? Oh no, Beatrice, you know what? We'll leave you. Well, no, this is actually your second question. So what is P? Then I'll leave you alone. Oh, so 4P is here, and this is in the 4P position. What does that mean P has to be? It's a fraction. 4 times what equals 1/3? 4 times what equals 1/3? This is simply all you have to do is set those two positions equal to each other and solve. I think you're going to be in a position of not dividing by 4 again, but multiplying by, not dividing by 4, but there you go. What's P? All right, and let's just see if the next part, what if 15 comes up again? 19. Michael. So what's the focus? You better not be touching that calculator, my friend. Who does that affect on the vertex? Is it the x coordinate or the y coordinate when I have to move up P? X or y coordinate of the vertex, Michael. Is he here? Okay. So what would that be? So you're saying the x coordinate doesn't change. Good. What would that be if I'm here? Look at my hand. Here's -5, and I have to go 1/12 above that. What would that just be mathematically without a calculator? What would that y value be? But negative. Nice. -4 and 11/12. It always makes me sad, students that cannot think fractionally. All right. And then directrix. I'm not saying that's you. This is why we're going through this exercise. Just go right to the calculator, press our buttons, and get our little magic answers, not knowing anywhere where it came from. That's why we don't know fractions. Okay, then what is a horizontal line? What's the equation of that? Is it x or y equals? And then y equals, then we got to go down from -5, 1/12. So what is that number? Ain't no thing. Chicken wings. Okay, so I don't need a coordinate plane. All I want to know is which direction is the parabola going so that I can know what math I would use to find those other two things. That's about as hard as it gets, getting fractional, numbers there. So, all right. So I wanted to review another completing the square. I think I did that before ellipses, did another circle, and then, and hopefully you're understanding the differences. Very minor, same process, but when you're trying to get a different form, a little different thing occurs. And then reviewing the graphing of it. So after we're done completing the square, we'll certainly review the graph. Okay, now here we go. And I did see some people run off to the printer, I believe. How many people printed the notes? So if you do it, okay, and that's going to benefit you here because it, and you do have my little writing there. But hopefully you can see the difference here. And I'm going to put an ellipse up here. I probably should have done ellipse, then hyperbolas, and then just done parabolas last because parabolas are really super unique compared to everything else. So I'm going to go back to an ellipse, and you might want to write this above. And just remember that an ellipse looked like this. And I'm just going to pick the x one, x minus h squared over a squared. Or it could be b squared. That would just say that there's a difference when the x-axis radius is smaller or bigger than the y-axis radius. But here's the thing, that's a big fat plus. Y minus k squared. And in this particular case, we're just saying the y-axis radius is smaller than the x-axis. So if you see that, then you will see the difference, no pun intended, with getting a hyperbola. There is a minus sign in between the squareds, not a plus. So plus sign in between, you got an ellipse. Minus sign, you got a hyperbola. You don't even know what a hyperbola is yet. But, and I didn't do the cones picture, but remember hyperbola, the two cones, it cuts right through the top, and you actually get what looks like two parabolas, but it's one hyperbola. It's not really parabolas. Something a little different happens minorly. Hide that too. Okay. So now here's a couple things you want to mark. And I will tell you this right now. The beginning of graphing is going to be almost identical to graphing an ellipse. But then there's just a couple things you got to switch after that. And as long as you start by graphing, even if it doesn't say graph, you're going to be better off. It always makes me sad when I see homework assignments. I think 1, 3, and 5 odd don't say to graph. But it makes me sad when I look at someone's piece of paper and they didn't graph. I think they're just copying the key possibly or something like that. Something nefarious that's not really legitimately doing the assignments. So you really should see these sketches when we do this stuff. Now notice the main things that we're going to have to take care of. And I know what happens. And there was a lot of setup here for me talking about this. And hopefully you just, sink it in and lock it in. Notice this first one is x squared minus y squared. Now I always think positive good, negative bad, English. So what I'm calling this one is the x-axis, or the x is the good component because it doesn't have a negative on it. The minus y squared. That's the bad axis. So this is when you get a right-left hyperbola. And I know what happens. Once I go through hyperbolas. Then we start jacking up parabolas, because then they start using this thing with parabolas, good axis, bad axis. And you got to write that and separate that right now. Remember what Aiden said at the beginning. How did he know it was a parabola? Because for every y, there was two x's. All right. And that's what you got to remember for a parabola, the trick. This is the trick for knowing how to graph a hyperbola correctly. So notice the second one, and notice h and k are with x and y respectively. Y minus k again. That's the good axis. That means the y-axis is the good axis. That means this will go up and down, not right and left. Okay, so I don't know what else I can say. You got to separate this with your thought process for parabola because they're not related at all. They have two completely different tricks, I like to call it, in order to get this memorized. It's not that I'm not going to cover these things. It's just if I reveal what the box says, then you would think it's like some sort of memorization with all these letters. Go to the graph and then find these things by looking at the graph. By the way, fine, some terms. Semi-transverse axis. That's half of the transverse axis. That's just the for this one. Let's go back up to this one. That's A. It's the good axis. It's the one, it's your x-axis radius in this case. In this case, it's your y-axis radius, right? So it's synonymous with semi-major axis and semi-minor, but the transverse axis does not have to be bigger than the other axis. And then what I call the bad axis, this is B for this one because that's the negative axis. It's the one that doesn't, it's the direction it doesn't go. So that's called conjugate axis. So we do got some crazy terms here. I get it. Just make sure you kind of know them. Hey, but then the one thing I did let you write and reveal is our Pythagorean relation that allows us to find the foci. Notice the difference for this one. It says a squared plus b squared. For ellipses, it's a squared minus b squared. If you look at me, here's an ellipse. It was a squared minus b squared because the foci must be smaller than the major axis. So the foci are inside the bowls. And then imagine me if I did do the string thing with ellipses and drew it. Yes, the foci have to be inside the bowls. For a hyperbola, here's A, C must be bigger than A because the foci are the serial. They got to be in the bowls. So A, C. C's got to be bigger than A. The only way C can be bigger than A if C is found from A squared plus B squared. All right. So I'm trying to common sense this out for the coin flippers that jack up this relation in between the ellipse and the hyperbola thing. You'll see that happen, and I'll hammer that point down more and more. The next thing I'm going to show you, absolutely do not write as well. I'm just going to reiterate everything that I said here and show you how confusing it could be if you look at all these letters when simple graphing will take care of having to memorize all those letters. It's awful. Remember when I first started teaching this way back in the 90s? Holy crap. I would tell them to memorize the letters, and it just didn't work out well. Because each set of sections has all these different formulas, is what it appears to be. When all we have to do is just have the knowledge of how to graph it, and then everything falls into place. And there you go. This is why I cut this out. But just be aware that there are going to be asymptotes, and I'm going to show you how easily to find those after you graph. So hyperbolas do have approaching dotted imaginary lines at the end. So that's why they can't technically be called two parabolas. Parabolas do not have asymptotic behavior. Okay, but I'm not showing you that as a formula. Not gonna do it. Okay, so here are two possibilities. Don't write this down. Look at these letters. Oh, I'm gonna faint. H minus A comma K, H minus E comma K, plus C plus A. Blah, 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 blah. It's all a bunch of garbage. I'll tell you exactly what you're gonna do. Just watch. Just watch. You're gonna pretend it's a hyper. I'm sorry. You're gonna pretend it's an ellipse first. You're gonna find the center. There it is. H some H comma K. You're going to do your x-axis radius, which is A. You're going to go A right and A left. Okay, and that's these points. And then you're going to find your y-axis radius, and you're going to go B up and B down. This is exactly how you found an ellipse. But then you're going to stop. What you're going to do next, instead of drawing an ellipse, is draw a box. Then you're going to draw these asymptotes that I just told you exist, but they're really easy to draw. They go through the corners of the box and through the center, and there are two of them. And then since this is an x squared minus a y squared, you're going to draw your hyperbola. And the hyperbola does have these as vertices because those are vertexes. Those literally act like vertexes for something that kind of looks like a parabola. So from there, we can name all the things that we need to name. And then all we'd have to do is our c squared equals a squared plus b squared to get our C move. And our C move is the foci. And notice that the C value is bigger than the move to get the vertices. That ensures the foci are in the bowls. So that is why should never make a mistake on what how to find the foci. Then I'm going to do one more thing that makes this easy. This is why I didn't let you write down asymptote stuff. Actually, I don't really need any other highlights. Look at these asymptotes. First of all, both asymptotes, let's get a student. Now, I'll wait till I get a specifics. Both asymptotes go through the center. So notice that they share that point, these two dotted lines. Then notice, this is grade school stuff. Notice the slope of these asymptotes. The slope of any line is rise over run. Notice the rise from this point to say this point is the y-axis radius over the x-axis radius. And then notice this other slope that I'll do in green is a fall of the y-axis radius and a run of the x-axis radius. So the slope of both of these happens to be negative plus or minus b y-axis radius over a x-axis radius. And I don't want you to make a big deal out of b and a. Who's b? Who's a? What's going on? It's actually irrelevant for a hyperbola. And I don't even need to be calling that. I should be calling it y-axis radius over x-axis radius instead of b over a. Then notice this one when it goes up and down. So this is the good axis. All that happens is you do everything the same. You do your y-axis radius, you do your x-axis radius, y-axis radius, x-axis radius, draw a box. We're going to draw it as a dotted line, by the way. Draw your asymptotes through the center. And then now that it's a y squared minus x squared, it goes up and down. And these are the vertices right there. Okay, but notice again on the asymptotes, it's still rise, which in this case is A for a letter, over run. Positive, negative slope. Okay, so finding the asymptotes is as simple as rise over run, the very first thing you ever learned probably about a line. A line has a constant rate of change. That shall be called the slope. And you learned that in grade school. So grade school stuff, as long as you draw your box, you should be able to find these asymptotes. And we'll cover that one more time. But again, there's a lot of things out there. We're just not learning things that we need to be doing so that we can move on, some of us. And then we come back to getting an equation of a line, and then people get panicked. Oh, I got to learn about lines again? You should already know about lines like the back of your hand. Some weird's going on out there for some of us, not being able to do some of this basic stuff. Really is. All right, don't go there, Mr. S. Caesar. All right. So those that didn't take the notes, those that didn't print the notes, yeah, there's some wordiness here. So I take a minute. I don't even think I took attendance, did I? Oh, I did. I complained and lamented how many people are absent. Just don't get that, man. I don't know. Okay, Caesar. What's the center? Yeah, and we should know that already because we had that with circles and we had it with ellipses. So we're going to start with the basic 0, 0. What's our x-axis radius? Doesn't matter what's minus or not. The x-axis, it's 6. And then what's the y-axis radius? And then that's what we do. We start off like we're graphing an ellipse. We go 6 right, left. We go 4 up, down. But instead of an ellipse, now we draw a box. I don't care that I'm green. I'm just had a color picked here. And instead of drawing an ellipse, we draw a box, and we instantly draw the asymptotes through the center and through the corners of the box. Then Caesar, for my glorious explanation from up there, which way does this hyperbola go? Right, left, or up, down? Good. Last hour student got it wrong. This hour's good. Good axis. X squared. Good. Positive. positive, x squared x, x-axis. X-axis goes right, left. Again, I don't know. I know what happens. People get these jacked up in their head when they're comparing it to parabolas. Gotta separate it. I'm saying it as a warning thing. Write them down. What's got to be remembered for this, and you won't screw it up. Okay, I think you've done enough. Boom. Student number 11. Nice, Isabella. What do we have to do next? Okay, vertices. So what are the vertices exactly as coordinates? Look at the vertexes and, what are those coordinates? Because I do have this right here, vertices. And? So I'm going to write it as plus minus 6 comma 0. All right, and I could just write them both. How do I find the foci? It's c squared equals a squared plus b squared. What are those two numbers I plug in? Last hour student said the wrong thing. You are good? Yep. And then 52, square root of 52. Do you know what that is broken down? Like doing radicals? Because I'm going to write the foci in radical form. But, so what times what equals 52? And that one thing's a perfect square. I'm going to get the decimal, though, for you. So I'll do that. You break down 52. 7.2. Isabella? Isabella, where'd you go? I think. No, something happened. Wait, no, 4 times 9 is 36. And besides, no, that wouldn't work. So 4. So you're saying 16 times 3? No, it's not 16 times 3. It's actually, I think it's 4 times 13 equals 52. So what does that mean comes out? What simplifies? What's the square root of 4? 2 root 13. Okay, and we're going to write it in terms of that. Okay, which way do we have to go for the foci? They are the serial. So which way do I have to move for the foci? From the center. You are correct. Notice I put 7.2 because here's 6 and then 7.2. Look at me. Our X marks the spot, just like I did with parabolas. I made it like an X just to make it look different, and then negative 7 root 2. So how do I write the foci over here in exact form using 2 root 13? What would the correct coordinate be for that, or coordinates? Okay, I'll give you a hint. It's either 2 root 13 comma 0 or 0 comma 2 root 13. Which one is it? And I didn't say the plus minus because I just wanted to go faster. So we went positive 2 root 13 and negative 2 root 13 comma 0. No coordinates, no right answer. You're gone. Okay, enter. Oops, student number 7.21. Never mind. 22. Nice, Natalie. Now we're going to do some asymptotes. Hey, Natalie, now that we're looking at this, I made this a grade school question. What does that line and that line both cross? What do they have in common? Where do they intersect? Or a better way of saying it, what's their y-intercept? So I don't need this because it's 0 and 0. Really, what I'm filling in for this equation of an asymptote is this, and I'm going to find what the slopes are. So this is what I was talking about with real numbers now. Let's look at the yellow line. What's the slope of this line if this is the rise and this is the run to get that slope? Because that's all that's happening. Now look at the equation. Actually, in the equation with our radii values, we should be able to get the slope. And then and you're going to reduce that, I hope, right? But what kind of slope is this? The blue slope. What kind of slope is that? Starts with an N. That's all I'm looking for. Negative. So your equation, 4 over 6 is 2 over 3. For both of these, you got a message there. plus minus 2/3 x. That's a simple equation of a line. That's the equation of both of those asymptotes. So it's really great. So you can turn off your mic now. It's really simple to find these things. It ain't no thing. Chicken wings. Beatrice, you're next. Did you already go? Oh, well. You know the calculator rules. So if I didn't have the calculator and I called on you once, then you might think, okay, good, I get the rest of the class off. All right. Take a minute for the non-printers. I could have done this the last one, but now we throw in the transverse axis things, and it ain't no thing. Conjugate axis. I know they're weird vocab words. Sorry, YouTube. I do want to give my class a minute to take these on, and I can't pause, as I said all year long, on this movie making software. Oh. I still have had nobody contact me that has missing grades. So that's got to get done, unless your grade's going to be what it is. But I don't want any Fs, so I'm probably going to have to contact the people that A, won't contact me about missing grades, and B, don't care that they're failing. So probably going to have to do that shortly here, just to try to get you to pass, because it's really hard to fail in the system right now. Really hard. So just had to do a couple things to make that happen. All right. Hey, who was it? Beatrice. What's the center? And then what's your y-axis move? Because that is listed first. My graph even shows it. And then what's your x-axis move? I hope you said 8. Kind of phased out there. 4. And notice I did that. 0, 0, 8 up, 8 down, 4 right, 4 left. Drew a rectangle. Drew a your asymptotes. Okay, so then that way we can find them later for somebody else coming in here. Okay, then one more thing, Beatrice. Which way does this go? Is it a right lefter or is it an up downer? And that wouldn't even be an option. It wouldn't just be right. It'd be right left, but it's not right left. Look up here what I highlighted. Y squared. Good. Which way does the y-axis go? What direction up and down is the right answer for this then? Good axis. Y-axis. This faces in the direction of the y-axis. And notice the asymptotes. It does. That's why I can't really call it parabolic, because what it does is it gets controlled by these and approaches, but does not cross. That doesn't happen with a parabola. So little minor difference there. Okay, so now the vertices. Let's get somebody else here. Mixing it up here. 5, 6, 7, 8. Abigail. Nice. What are those vertices? Well, those are just the vertexes, and I just want them as a coordinate, and I just highlighted those. So go ahead and chime in. What are the vertices? Oh, no, because plus or minus 8 comma 0 goes right left, right? Oh, no, those are the endpoints of the conjugate axis. The vertices are the actual vertexes of the two things that look like parabolas. So we just got to make a switch on plus minus 8 comma 0. And I guess you weren't technically wrong saying plus or minus 0, but that's okay. Doesn't really matter. All right. So the things that you just mentioned, I'm going to just go ahead and put these in here. The semi-transverse axis, they're looking for a length. Transverse axis is the good axis. It's actually just the y-axis radius. The good move that connects the vertices. The length of the transverse axis, 16. It's a length of 16. So they ask these silly little questions just to see, do you know what the good axis is? And then semi-conjugate axis, that's the bad axis. That was the one that's not connecting the vertices. The only purpose of it is to get my box so I can draw my asymptotes. The length of it is, well, 4 plus 4 is 8. So that's what that length is. Okay. Student number 11, nice. Isabella again. Your lucky day. And you have the same exact question. How do you find the foci? C squared equals what number and what number and what operation? Oh no, it's plus. Because if it was minus, your foci would not be in the bowls. It's got to be plus. The C value must be greater than A. Okay, so that's why it's got to be plus. 80. Oh, we're going to do it again. What's 80? What times what? Take a 2 away from 10. What's 2 times 8? You see how I did that? Watch how I did that. 8 times 10. Neither one of these are perfect squares, but I'm going to take a 2 away from 10. And now I got a perfect square times a non-perfect square. What's the square root of, what would this be then? 4 square root of, you didn't look over here. I borrowed a 2 from the 10. 2 times 5 is 10. So this is what 80 is. You understand what I'm doing here, right? This is 2 times 5. And then I put these together because that's a perfect square. So what's the square root of 16? What's the square root of 16? Okay, so what's the 4? And then it's root 5. So I was trying to show you a trick on how you started with 8 times 10 as the product equaling 80. Well, I don't have perfect squares in there. I'm trying to reduce or simplify this. So that's what I was trying to show you there. Okay, square root of 80, 8.9. Okay, so 4 root 5 or square root of 80 is approximately 8.9. Now, Isabella and everyone else, if you accidentally did subtraction, then this is what would not happen. 8.9. You would not get your focus in the bowls. You'd be short. And then that should be an indication that you did the wrong thing in your formula. For ellipses, it's minus because the foci must be inside the ellipse because that's what draws the ellipse or makes it happen in the real world. Okay, so what are the foci then? How would you write that as a coordinate, Isabella? Using 4 root 5. Absolutely. And then just remember on our next one, if the center is different than 0, 0, it's just the y coordinate that's affected by 4 root 5. So you'd have center x comma y plus or minus 4 root 5. You should be able to handle that. Okay, next. Oh no, square root of 80, students. I gotta change my calculator. 19. That feels like Michael. Are you still with us? Poyos. Polos. What's the slope of that yellow line? What's the slope of this blue line? What is the y-intercept of both of these lines? So I couldn't care less about the x1 and y1 because they're 0. So really all you're filling in for the equation of the asymptotes is y equals mx. Got it? So easy it is. All right. It's ain't no thing, man. That's a grade school question. Student number 20. Nasser. Okay, we'll give you a second to combobulate yourself. That's the opposite of discombobulate. Ah, you're killing me, Smalls. Okay. Alrighty. Might be someone else that might need a couple things here. Okay, moving on. Hey, and then always I don't put copies of notes. Good golly, you got so much out there anyway. Told you before, you could always open up the YouTube video. You don't even have to listen to my voice. You could just pull the YouTube until it shows the notes that you needed to copy down that I went too fast with. All right, should be able to happen. Hey, Nasir, as you're slowly writing this down, if you didn't print the notes, what's the center? Be careful. Okay, and I'll write this. I'll actually spread this out here. This is all we need. Yep, and that's the be careful component. That happened with circle wrong. That happened with the ellipses. Sometimes they wrote it in reverse, y squared and then x squared. And you had to be careful on what the center is. You get the center wrong, you get everything wrong. Hey, Nasir, what's the y-axis radius? Still going to use that term even though there's not a circle or an ellipse. 3. What's the x-axis radius? Okay, so from the center, you'd be a silly fool if you don't graph this, because once you graph it, everything's easy to find. Silly fool if you didn't graph negative 2, 3, and then go 3 up, 3 down, 2 left, 2 right, and then draw the box and draw the asymptotes. Doesn't take long. So that's how you draw an ellipse or a hyperbola, sorry. Hyperbola because there's a minus sign in there. And then Nasir, which way does this go? Is it up, down, or right, left? It is up, down, and you're done. Turn off your mic unless the calculator loves you again. So this is a hyperbola that's going up and down, which dictates where the foci are, up, down. Hopefully get that right if you get called next. That's why we got to get all that stuff. Okay. So number 6, Aiden again, back to you. What are the vertices? Well, I want them in the equation format, and they are these vertexes, these actual vertex things. What are those as coordinates? Correct. Just think of just think of negative 2 comma 3, and I go 3 up from 3. I thought you said 6. Yeah. Okay, good. Mixing it up here. Student number 17. That feels new. Ryan Oster. Nice. How do I find the foci? Now we're rolling. C squared equals A squared plus B squared. What numbers go in there? Ryan? Oh, no. Your mic is on, but I can't hear you. Are you doing something on purpose? Hey, put up in your hands how much it ends up being. Like, what does C squared equal to? Let me see your hands. Let me give you a hint. It's bigger than 10, Ryan. This is how we improvise when the mic doesn't work. Ryan, you're not putting your hands up. So it's bigger than 10. So 10 plus what? 10 plus C squared equals 10. I don't think he gets what I'm trying to do here. What's 9 plus 4, Ryan? Put that up as hands. And then what? There you go. 13. That's what we were trying to get at there because your mic doesn't work. All right. Now, I don't have a way of simplifying that, so we're just going to get the decimal. Ryan, you're going to have to do this with your hands. Which way do I have to go the square root of 13 or 3.6 in order to draw the foci? Which direction? Up. Good. And what else? Down. Nice. Okay, so you can't do this with your hands, so you're eliminated now. Convenient. All I have to do is have my mic not work, and then I don't have to answer questions. Oh, I'm sorry, Isabella. You're up again. And then Isabella's going to say, my mic doesn't work. Isabella, what are those as court? Don't sound sad. This is fun. What would that be as a coordinate then using the square root of 13? Like who gets affected when I go up and down? Oh, so close. You didn't take the 3 and then go up root 13 and down root 13. So it's 3 plus or minus root 13. Okay, and that's how you can write this as exact. As approximate, you go up 3.6 and down 3.6. That is bigger than 3. That ensures that the foci are in the bowls. All right? Okay. And then last, oh, Isabella, how many times is it? Is that 4? Okay, we won't, I think it's 4. Let's not exaggerate. Sarah, we're going to go to Sarah. Sarah? Oh, did I not get her in attendance? Sarah, what? Oh, I almost said her last name too. What the heck? What kind of attendance am I doing here? I'll have to check that later. Okay. 3. All right. Who's that? Natalie. You can blame Sarah for this. Okay. Oh yeah, we're doing great. So Natalie, what do both of these lines cross? What do they have in common? Starts with a C pertaining to this question. So, if you remember, and you should, If you remember the equation of a line in point slope form, that is the center. So it's y minus 3 for both of them, and then x minus negative 2 plus 2. This is an equation of a line in point slope form. Okay, then here we go again. You can either look at the radii values or just do simple rise over run. What's the rise here to get from here to here? And then what's the run? But then what kind of slope is this when I fall and run? You are correct. So it's plus minus 2/3. Again, I'm sorry. You said 3/2. I did the old flipperoo on that. 3 y-axis radius, 2 x-axis radius. This always ends up being the slope for rise over run of the asymptotes. Ain't no thing, chicken wings. And I'm telling you, you can leave this like this. We'll accept that, even though these do get two completely different lines. Like, I think you could see that the y-intercept of the negative slope is 0. The y-intercept of the positive slope is 6. So actually, that's what both of the equations are separately if you solve them. Y equals plus minus 3/2, wrong. This is the negative slope. The negative slope has 0 as a y-intercept. And then the other one, y equals positive 3/2 x, has 6 as a y-intercept. So if you were to separate these into two separate equations and solve for them, this is what they would be. We just always let people leave their asymptotes like this in plus minus form and just put them in one situation. So just so you know, if you're really good with equations of lines, that's actually what happens. Oh man, we're just getting warmed up because now guess what we got to do? Complete the square. I don't know how I missed that in the attendance. I think there's just too many B's. Like I think I skipped over one of the last names with a B. And okay, it's gonna make an attendance shift. Did I even take attendance? I did. Sorry. Yeah, interesting. Save. More absences than I actually thought we had. Not good. Okay, all right. Boom. You know it. I know it. Let's just show one at a time. And then the student that I got was Skylar Davis. Remember that? Oh, Skylar, you could sue me. I said your last name. All right, Skylar. Sorry about that. No one's watching these videos anyway, so it doesn't matter. Skylar, first of all, my first question is how come I know this cannot be a parabola? Why is it impossible for this to be a parabola? This one right here. You are correct. And now here's where we have to say we know it's a hyperbola right away. And it has everything to do with what we just first showed you. For a circle, this would be a circle. That would be a circle. This would be an ellipse. It's because the x squareds and the y squareds have different coefficients, but they're still both positive. And then this is a hyperbola because one of the square terms has a minus. You are guaranteed at the end of completing the square on this that you're going to have a minus on one of the square terms. So this is why this sticks out like a sore thumb of being a hyperbola, not in this case, you might thought it was a circle because the x squared and the y squareds have equal numbers. No way. This is a hyperbola because of that negative square term. And then also remember what you said, Skylar. There's no way you should mess up when you have a parabola. Parabolas only have one squared term. All right, so it's got to be a parabola when that happens. And then this is what you're going to do. Probably slow it down a little bit. Of course, you're going to get the x's together. Of course, you're going to get the y squareds together, but you already should see a problem. You cannot complete the square on negative y squared. You can't. And that's when you have to do something that we did with ellipses, sort of. You have nothing to do with the x squared. Skylar, going to ask you one more question here, so be ready. But I'll get this set up for you because this is the new part a little bit. Knowing that you cannot take completing the square with a negative y squared. You have to pull that negative out. I'm going to write it as a negative 1 being factored out so that you get that. I should make this plus a negative and then group these, so that I understand that's why I pulled out a negative. And then, Skylar, I don't want you to make this mistake, so I'll put it in there. That makes that 4y negative now because it had to be grouped with the negative y squared. Okay, Skylar, mic on. What's the first blank? What's the second blank? Okay, so 1 and 4. Now it's the time to be careful. What's the third blank? I probably scared you by be careful. What do you mean? Now be careful. What's the fourth blank? This one I really mean. You are right. So you're a master at completing the square. Many of you are. Some of you don't even know where to start. I can't help you at this point. You can only teach something so many times before it actually sinks in. All right. You're good. 15. Beatrice, this is like number 3 for you. What is this in factored form? It's the whole point of completing the square. Squared, right? And then we're going to make this plus negative 1, just that big fat minus now. I don't think we need to see the 1 anymore. This is where the minus of a squared term comes in. And then what is the second set of parentheses? Squared. And then equals, I could do this. All right. So, okay, here we go again. If this was plus, then this would be a circle. That's what I want you to understand with a radius of root 3. But it's not. So don't write that down. I just wanted to put that in your head why this is still a hyperbola. That minus makes a good axis bad axis and makes this get fractured into a hyperbola. All right. And we're not going to find any other information on this just because we're going to have some root values. All right. And, decimals in order to graph it. I just want to move on from it. Okay. And I'll leave this here for people that are writing a little bit on the slower side. Student number 4, 1, 2, 3, 4, Brianna. Nice. When I group these 12s, wrong. I don't know what. Okay, so I just actually said your answer that I'm going to come up with. When I group these together, oh, that's good. When I group these together, what do I have to pull out? What do I have to factor out? So we pull a 12 out. I'll do the math for you if you were scared on and just making sure you don't make a mistake. I have no idea why I wrote a 6 there. I think it's because I had 6 in my mind because 72 divided by 12 is 6. So I got a little ahead of myself. Then blank. Okay, now be careful. When I group these two together, what do I really have to take out? Brianna? You are correct. And we're going to write it like this. Plus negative 4 and then y squared, don't make a mistake on this. We're done with that other one. Plus 4y. Blank. And then Brianna, what's over here? Notice what's left that's not highlighted and I got to move it. So what is that over here on the right? Because people make mistakes on this all the time. Yeah, you got to subtract it. Don't be all proud of yourself with those blanks and then forget a basic little thing there. Okay, you're off the clock there. Student number 16, Amanda. What are these 2 blanks? So completing the square, what's this first blank? What's half of negative 6? And then square it. So what does that become? What's the other blank? And then what's this blank? It's not 9. What would I have to do? I would have to put on my calculator or actually just tell me the number. I could do it or you could do it. Okay, well, we got to get going here because we've been doing this a lot here. So it's 12 times 9. All right. So now you have to tell me what the next blank is. 90 and 108. Okay, so what's the last blank? Doing what I just did there with that getting 108, negative 16. Okay. All right. And then what's this factored? Student number 1, Muhammad. 12 times. What does this become? A. What's this factored, Muhammad? It's the next step. X minus 3 squared. Don't go anywhere, everyone. That bell is meaningless. You all show up like 4 minutes after that bell anyway. Say that every day. And then what's the second one factored? And then all you have to do is just remember that I said this. I add these up. I think I got 48 last hour. But just imagine if this was negative 48. All that would do is switch who's got the minus sign on it. It would switch the bad axis, good axis. So, but that's not what happens. When we divide by 48, we still have a minus y squared. Hence the reason this is a hyperbola. And knowing it's a hyperbola to start off with, you're going to have questions on the test that ask, what is this? And you should know right away that that's a hyperbola because we have two square terms, but only one of them is minus. So that means one of them is going to be minus at the end. So in a millisecond, you should be able to say hyperbola and not have to do all this if that's all they were asking. Of course, we're going to ask you to complete the square minus, instead of plus a negative, y plus 2 squared over 12 equals 1. And then, of course, the center is 3 comma negative 2. X-axis radius is 2. Y-axis radius is unfortunately square root of 12. So you'd have a decimal y-axis radius. Draw your box, asymptotes, move on. Okay, so that should all be good. All right, just one thing to mention, too. Just realized I don't know if I said this or not, but I put it right here. I don't know if anyone ran it. I did say it. No one really responded if they actually did the homework or not. But originally, I had the keys was wrong. So if you want to look at 49 and 50, Mrs. Westberg's class caught it. Made some real silly mistakes. Brain was just not functioning, I guess, when I made that key. All right, we'll see you tomorrow. I don't know. We'll do something. So probably complete the square craziness. Okay. Hasta la bye bye. I got to stop this video.